Hi, I'm Mr. O'Connor. We're going to be talking about using algorithms today to solve a 3-digit by a 1-digit multiplication problem. We are in the Common Core way of thinking, so we're not going to teach students anymore how to memorize how to do an algorithm. We're going to talk about breaking the algorithm apart so the students know what's going on and how it works. So immediately I have my students always break down the number into expanded form, or we call it value form. I think it's important they know that when we do multiply a number by another number, we're multiplying the value of each digit by that number. So when they see that it's not 3 times 3, it's 300 times 3, that 1 is in the tens place, it's 10 times 3, and the 2 is in the ones place, so it's 2 times 3. If they can write this down, immediately they've already deepened their knowledge. So we start at the ones place. It's a simple fact fluency problem. 2 times 3 equals 6. We come on over to our expanded form section. We show 2 times 3 equals 6. The misconception occurs on the next step when students believe they're multiplying 3 times 1, and that's what we used to teach them. But that 1 is in the tens place, so we're actually multiplying 3 times 10. And that's why when we get our 3, it goes in the tens place. So have them label it. Make sure they understand it, and then come on over to the expanded form section and show them. See, that 1, when we were in expanded form, became a 10, so we did 10 times 3, and we got 30, or that's 3 tens. And I made a mistake. I definitely should have labeled my 6 as a 1, 6 ones. Or some teachers like to teach it as units, so you can label it as 6 units. Ones gets kind of confusing. And then our final step, we're going to go to the next place value. We're going to do 3 times 3, but that 3 is not a 3. That 3 is in the place value of 100, so it becomes 300. So 300 times 3 is going to be 900. So that 9 needs to be labeled that it's not just a 9, it's 9 in the hundreds section. We come to the expanded form, they see it. There it is, 9 with the 2 zeros. The student should start making the correlation. They see 2 zeros behind a digit, they know it's in the hundreds. They see 1 zero behind a digit, they know it's in the tens. And they can use the way that we did this problem as kind of a checks and balance system. They do the algorithm, they do it in the expanded form, they should get the exact same answer. It's not about the quantity of problems that you're assigning students to do. It's about the quality of work that these kids are able to give back to you to represent and show their abilities and their understanding of the concepts.